In this video, we're going to take a look at working with render kernels in Octane for Cinema 4D. A render kernel is basically the render system that you're using within Octane to determine how lights interact with surfaces, how the lighting is calculated, things like acoustics, reflectivity, and so on. We'll get into the details of each kernel in upcoming videos. In this video, I just want to take a look at how you set the kernel for your scene. I'm using the robot and pilot 01.c4d scene for this project. And it consists of just a couple characters, a little space pilot and a little robot, and they're looking through a giant magnifying glass for whatever reason. The main point of the magnifying glass is to show that we're rendering caustics here onto this surface as the light goes through the magnifying glass. And that's determined largely by the material, the lighting, but also the render kernel. So to set the render kernel, you go into Octane settings. This will pull up the Octane settings window, and you can see the first tab here is called kernels, and we have a choice of several different types of kernels. I'm currently using the PMC kernel, which is the most physically accurate render kernel available in Octane, but it also is the slowest, so it takes the longest to render. But you render things like these caustic light patterns as light goes through the glass, as well as you can see these reflections on the ground as the light strikes the metallic surfaces and they reflect on the ground. All of that is created through PMC, and you can see there's a large number of settings here that we'll go through in more detail in an upcoming video. But if we want to change the kernel, we can use this menu. So for example, if I switch to direct lighting, we get a nice, fairly clear image fairly quickly. I can always up the samples, of course. Let's set this up to 1024. But you also notice that we're not getting this caustic light pattern as the light goes through the glass. We're also not seeing as far into the helmet here because of the helmet glass. We're not seeing the little character on the inside. But we do have a number of settings here that we can use to tune this. So direct lighting is a great kernel when you need to render something quickly that might not need caustic light patterns or reflections, or maybe you want something that's fairly quick where you can set up the lighting and the shaders. And then as you start to develop the scene, you can switch to a different kernel. So we have direct lighting. We also have path tracing. Path tracing is a physically accurate path traced kernel. It's, in terms of quality, it's between direct lighting and PMC. So it's a bit faster than PMC, but you may not get as nice caustic light patterns as you would with PMC. So generally speaking, you probably want to use path tracing for most of your scenes unless you're in one of those situations like this one where you need a nice caustic light pattern or reflections of the ground, in which case you might want to try PMC. But try path tracing first before you switch to PMC. And then the other kernel that we have is info channels. So info channels allows us to see things like the wireframe, Z depth, material ID, and other ways to visually represent the information that we're seeing in the scene, like ambient occlusion and so on. So info channels is essentially a diagnostic tool. This is a great one if you're just trying to find out what's going on with the scene, or maybe you're loading a bunch of objects for the first time and you want to see it without having to use these other more realistic lighting methods. Another way to switch between kernels is to use the menu here in the live viewer. So we have DL for direct lighting, PT for path tracing, PMC, and then of course we also have a number of kind of common info channel ways to look at the scene. So if you want to see the alpha channel, Z depth, UV, and so on. Normal, wire. So the next few videos, we'll dive in deeper to the settings found in the Kernels tab of the Octane settings window.